Alright. What's up mga Chimek? It's been a long time. I'm your boy, Sir Zello, now with our new episode of our Chemistry in Session. So for today's session, ladies and gentlemen, without further ado, we are going to simply talk about naming bases. No? Supposedly this was for the last time, no? But we left it out. No? We separated it for naming acids, though it's very similar and it's actually a part of the naming of the compounds, the last part of naming of compounds. So without further ado, let's get it on. Alright. So for today's session, again, as I've mentioned, we're going to talk about naming bases. But what are bases? No? We can run down these properties that they have, but I'd like to highlight some point. No? Parang si bases are the opposites of your acids. No? They are the arch enemies of your acids. Similarly, they often taste bitter. No? They are not as sour as our acids. If you taste your own acids or even different acids, they are basically used for making soaps, and they are slippery to touch. And then they turn the litmus paper into blue, unlike acids, which turn litmus paper to red, no? From blue, red, acid, no? The BRA. That's my acronym for that, BRA, or the BRA. When the blue turns to red, that's acid, but when the litmus paper turn to blue, that's your base. And then they do not react to the metals, no, like acids do, and they are used, no, when they react to acid, they're used, or they are to form salt and water. So si bases in general, usually these are your canceling machine for your acids. Oftentimes, diba, when we eat a lot during fiesta, during birthdays, we tend to have this so-called hyperacidity, meaning extra acids in our body, specifically in our stomach. That's why we take our antacids. These are your bases. So we'll run down to some of them, some of the few antacids that we are actually intaking. Now, as we proceed, we will also learn how do we name the compound of anyways, that's an error. That's not a base. So I just woke up. So anyways, how do we write the chemical formula of a base, and how do we name a base? No, that's not acid. So X, it's not acid. I-erase natin. Erase. Diba? I-delete natin. And we cross it out. X ka, X. We are going to talk about base. No? How do we know? First, if it's a formula of base, and how do we name base? No? Basically, bases are a combination of your metal or your NH4 cation, diba? Your ammonia, if you can still remember, our cheat sheet or our list of polyatomic ions. And then it ends with OH, which we call hydroxide. So familiar? Does it sound familiar? Our hydroxide. So very simple. If it's again a metal or an NH4, you know your metal well, your group 1, 2, 3, and then your transition metals along with your OH. Then it's a base. So let's put it into practice. Let me remove my face here. Alright. So we have Na, a metal, and OH, a hydroxide. So isulat natin yan dito. Automatically, when oxygen is accompanied by a hydrogen, we call them hydroxide. This OH is always our hydroxide. And we know that Na, due to common use, but you can check it out in your periodic table if you are not yet familiar with the symbols. And this is our sodium. Now, how do we write the chemical formula, or how do we combine this metal to my hydroxide or my OH? So simply, the same with combining metal to non-metal, if you can still remember ionic compound, we have to know the valence electron so that we can anticipate the charge of our cation. So looking back, we go back in our periodic table and determine the group number of our sodium. And again, why do we do that? Very good. Now, we do it in order to identify the valence electron. The group number will tell you the valence electron. Since sodium is in group number 1, therefore, my sodium will have 1 valence electron, and then it will release 1 electron, making it a positive cation, or Na plus in particular. While my hydroxide, so this is the interesting one, and the good news, OH always assume a negative charge, no, without a numerical value rather than 1, no, or negative 1. So if you can notice, our acids are H plus, while our hydroxide are OH minus. So easy to remember, OH minus. And then we go back, sodium, OH minus. We balance the charges. Same with our ionic compounds. And zala, easy peasy. We have your NaOH. Sorry for the the bad handwriting. And we simply combine the name. Now copy the name of our cation and then write hydroxide. So we have sodium hydroxide. Now easy peasy, right? But again, this will have no value until we appreciate its it's important. Sodium hydroxide are used, no, in making your soaps. Usually, ang ginagamit for babies are the non-acidic base soap. So, ganito yung itsura nila. Though most of the bases looks like this one. Alright, so we use the sodium hydroxide for detergents for your soap. Sige, let's have some more example. How about magnesium and OH? So again, we write their name, magnesium. You can try this on your paper, by the way. You can pause the video if you can still remember. Pero kung hindi na, you have to again watch the video, hydroxide, or read the handouts that has been given. So magnesium hydroxide, we check their valence electron and their ion charges. OH is always negative. There you have it, negative. Mg is in group number 2, therefore we'll have 2 positive. So kung nasashock na kung saan to galing, go back to the video, to the earlier video. Pero kung nakasabay pa kayo, very good. You already acquired the skill despite your score in your midterms. But mostly, they got high score. So very good. I commended mga kachimek. So, what's the next step here? There's a problem because your magnesium has 2 positive while OH has only 1 negative charge. So again, you either add an OH here, or the technique is to use the crisscross method and then transform it to its empirical formula. So there you have it. You'll have Mg. Sige, wag kang maglag ngayon. And then OH. But since we have more than 1 hydroxide, we enclose it in a parenthesis. So again, common mistake. If there are no more than OH or hydroxide, do not place them into parentheses. Yun yung common mistake. So we add a subscript here to indicate that we have 2 hydroxide in this particular base. And the name is simply, we combine them, magnesium hydroxide. Alright? So let's try this one. Please pause the video and then solve this one. Hopefully you've paused the video. Sige, without further ado, aluminum is in group number 3. So we'll have Al3+. OH is common. That's OH negative. And we forgot the name. So this is your aluminum. We do not write aluminium. We use the word aluminum. Yan, aluminum. And then, again, our hydroxide. I should be using the digital pen, but I forgot to install it. So I'm using my mouse instead. Aluminum hydroxide. So AlOH3, let's use the crisscross method. Al3+. Sige. And then OH negative, my hydroxide. So we use the crisscross method. The superscript of my aluminum will be the subscript of my OH, and same goes for my OH. There, this becomes Al parenthesis. So ito yung common mistake, OH, and then the subscript will be 3. Jala, and chemistry is very, very, very easy, you know, if you mastered the skill needed in doing such. Alright, so ALOH. Hopefully you got it right. And again, what are these things? No, maybe you haven't noticed. These are your antacids. Some are used for diarrhea. Some are used when they have constipation. But you're familiar with Kreml S for sure. That's literally your aluminum hydroxide and your magnesium hydroxide. And you'll know that this is your formula. So you'll have now some examples, no, probable examples for your PT. Kreml S. Alright? Sige, please try these exercises. Sorry lang. Please try these exercises. Pause the video and then solve. Alright, hopefully you were able to solve this for at least 5 to 8 minutes. If you did that, meaning you're already a chimek. So these are the answers. Congratulations, and see you again for the next episode of Kachimek. Bye-bye. Peace out.